Hi there, and with this lecture we start a new section in which we will discuss Python lists. List in a Python is a built-in data structure, which means that it comes with the standard Python library. There are other built-in data structures in Python, such as tuple, dictionary, and set. Here, in this course, we will look at lists, dictionaries, and tuples. So let's start with lists. A list is a data structure that holds an ordered collection of items. Example, you can store a sequence of items in a list. Here, ordered means that the way that you declare a list, it stays as it is. The place of elements is not changing. It's easy to imagine a list if you think of a shopping list where you have a list of items to buy. Except that you have each item on a separate line in your shopping list. Whereas in Python list, you put commas between your items. It's expressing like this. The list of items should be enclosed in square brackets so that Python understands that you are specifying a list. The values in list called elements or items. There are several ways of creating new list. The simplest way to enclose the elements in square brackets. For example, here we are creating the list of integers. We are just enclosing these integers inside square brackets. Here we are creating list of string elements. Here again we are just enclosing the strings with the square brackets. The main difference between array and list is that here the elements of list don't have to be the same type, which means that we can create a list like this. Here we have a string value, here we have an integer value, and here we have float value. We can mix up these different values and create one list over here. Even if we go in advanced level, we can create a list inside another list, which means that if you see the elements of the list here, the first element is string, and the second element is float, and the third element is integer, and the fourth element here is another list. When we count the elements of list inside this list, it will be 4. Nested list is taken account as one element. So if you have a list inside another list, this is called nested list. Let's see how this is working in practice. So here in Visual Studio Code, let's see how creating list works in Python. So first of all, let's create a list of integers. I will put like this, integers. Inside square brackets, we will put 1, 2, 3, 4. So if I press enter, it's created. So I can print out the value of these integers. As you see, it's printed the values. So our list is successfully created. Let's create another list with string values. String list is equal to, once again we will put square brackets over here. Let's add some strings here, milk, cheese, and I'll put butter. This is our shopping list. So we create it here. If I press enter, it will be created. So I can print the value of this list over here. We can see that it's successfully created. So our list is successfully created. Let's try another list with mixed values. So here, mixed list I will create. I'll put values. For example, first value will be integer, then I'll put float, then let's put another string value, spam, and let's say one more time, print this out, list. You see that the list is successfully created. Let's try another example where we will create a list inside another list. So which will be nested list. So in here we will create nested list equals, one more time again, square brackets, we are putting 1, 2, 3, 4, Then here I'll put 1.5, 1.5, 1.6. Let me create another list inside this list with string values. Let's put test. It will have only one value. If I click the enter, it will be created automatically. So I can print out the values of these nested lists over here. So you see that this list also is created. So that's how we are creating a list in Python. If you want to create an empty list, we just need to put something like this. And we can print out this empty list, empty. You see that there is no element inside our list. So the creation of list is like this in the Python. So hopefully everything is clear now. Now in the next lectures, let's see some other operations that we can perform on lists. Hi there. Now in this lecture, we will look at how can we access elements of the list and traverse through lists. As I said before, I'm not going to show you what's happening when we access or traverse through loop in the memory. Because I showed you this in array section, the logic behind the list and array is same. If you want to get more detail, I recommend you to go back and review the array section. So the syntax for accessing the elements of list is the same as for accessing the elements of an array. Once again, here we will use bracket operator. The expression inside brackets will be index again. So let's one more time create our shopping list. Shopping list. I'll put here milk, cheese, and butter. Okay, if you want to access an element of list here, we will use a bracket operator with index. As you remember, in array, the index starts from the 0. Here is the same, the index starts from the 0. So this will be 0 index, this will be 1, and this will be 2. So if I want to access the first element in the list, I will write something like this. Print shopping list with 0. So this way we can access the first element in this list. So let's run our code. Python 3 list operations. So you see that our element is printed over here. If you want to access this second element, we will just need to put one here and save the file and run it. We will see that the cheese is here. Our second element is cheese. You can think of a list as a relationship between indexes and elements. This relationship is called mapping. Each index maps to the one of the elements. List indexes work the same as array indexes. Any integer expression can be used as an index. For example, if you try to read or write an element that does not exist, you'll get an error. So let's try. We know that we have 3 elements here, which means that our maximum index is 2. Let's try to access with index 3. Let's see what will happen. Let me just clear here and run our code. You see that it shows that list index is out of range, which means that we are providing bigger index to access the elements, and this element does not exist in our list. For accessing elements, we have another way, but in this way we are not accessing the element, we are checking that if this element exists in the list or not. There is an in operator for this. By using in operator, we can find out if an element exists in this list or not. So this is working like this. Print, for example, milk in shopping list. If this is returning true, it means that this exists here. If it returns false, it means that milk does not exist here. Let's run it. You see that our expression returned true, which means that we have milk here. Okay, if I write a different thing here, we will see that it returns false. So if I write bread here, so save and run it, you see that it returns false, which means that bread does not exist inside this list. So in operator is also useful for accessing elements, but in this case it's just returning boolean value, true or false. So you might be interested, what if we provide as index minus value? What will happen in this case? So in this case we are accessing the elements from the backward. So for example, if I just copy it from here and run it for -1 value, as index I will put -1, you will see that in this case it will return butter. Minus value starts from here. So if I put, for example, -2, you see that it returns cheese. So what will happen if I put -4 over here? Let's try it. You see that one more time we are receiving list index out of range. So our index starts from 0, 1, 2. But when we come reversely, when we come from backward, then it does not start from 0. It starts from -1, -2 and -3. When we reach -4, it means that it's out of index. So that's how the accessing of elements of list is working. So let's see how can we traverse through this list. The most common way to traverse the elements of a list is with loop. So the syntax will be like this. If I just write any loop here, loop I in shopping list, I can print I. This will visit each element of the list and print out the values. So in the first case it will print milk, then cheese, then butter. Let's run our code, we will see the result. So as you see, this loop traverses all elements of the list. So first it goes to milk, then it goes to cheese, then it goes to butter. So it's traversing through all elements of this. So this is the common way of doing this, but we have another ways to traverse through the list elements. In this case we are just printing it. So what if we have an integer list and we want to do some operations, mathematical operations on this list? We cannot use this formula. In this case we need to just traverse through the list using indexes. In this case I will use again loop, but with range and length function. Here I will use for I in range, then I need to take length of list. I'll put shopping list. Then I can update, for example, the values to some standard value. Let's just do something like this. Let me take shopping list I equals, let's put plus sign at the end of these strings, which means that we have done our shopping. So we have bought everything inside this shopping list. So I'll put like this, then it's going to be shopping list plus. So if I save this and run this, because I haven't printed out this value, because that's why it's not showing anything. If I print out this, you will see the values. As you see, for each element of the list we have put here a plus sign, which means that we have bought everything. So in this way we can do some update operations on the elements of the list. So you might be interested, what's the range and length function over here? The length function is returning the value of number of items in a container. So here we have a number of 3 elements. So here we will return 3. But you might be now interested, if you put 3 here, it should return out of index error. In this case, range function saves us, because range function works from 0 to n-1, which means that if you put here 3, it will go till 2. So in our first case, it's coming shopping list with 0. Then in the second run, it comes shopping list with 1. Then in the third run, it comes shopping list with 2. it never reached to the element 3 because the functionality of range function works like this. So you might be interested if we have empty list. Can we traverse through empty list? We can write a loop through empty list, but this code will never happen. So for example, if I create here an empty list like this, and if I try to traverse through it for I in empty, for example, print that I am empty. So if I run this code, here I forget to put I, this code will never print out. So to make our thing easier, I'll just comment this part and run our code. You see that we don't have anything returned, which means that when you traverse through an empty list, it's not executed. So because we don't have any element inside this list. So this is all for accessing elements of the list and traversing through the list. And hopefully you understand how we are traversing and accessing the elements of the list. See you in the next lecture. Hi there. Now in the last video we have learned how can we access element of the list and how can we traverse through list. Now in this video we will look at how inserting and updating elements work in Python list. Lists are mutable data structures. That's why you can change the order of elements in a list or reassign an item in a list. When the bracket operator appears on the left side of an assignment, it identifies the elements of the list that will be assigned. Let's say we have a list of integers like this. 1, 2, 3, 4, 5, 6, 7. Now if we print out this list, we will see that the order of elements appear as we declared them. You see that the printout in the console is same as the way that we declared the elements. So this is because lists are ordered collections, meaning that the order of elements will be the same order as we declared them till we change the order. So now we know that lists are ordered collections and they are mutable. So we can update the elements of any list over here. To update the element in the list, we need to access the element and then assign a value to it. As we said, we will use bracket operator over here as well. So here, for example, if I want to update third element in the list, we know that the index starts from the 0, so the third element's index will be 2. So I'll put here 2, should be 2, and let's update to this 33. And let me print out the list one more time. Okay, let's run our code. You see that this is our initial list, the way that we declared, and this is the updated list. The third element over here is updated with 32. So to update an element in a list, we just need to access the element inside the list over here, then assign a value to the element. So here we are using bracket operator one more time. So if you try, for example, another example, my list, for example, if we try to update fourth element, this is fifth element actually, the index is 4 to 55, and run our code, we see that here the third element is updated to 33 and fifth element, which is the index 4, updated 55. Here you see that previously our list was like this, now the new list is like this, so the elements get updated. So you might be interested, what is the time and space complexity for this operation? So the time complexity for this operation is O1, because we know that accessing an element of a list is O1 time complexity. This is the most beneficial part of lists, because lists provides us very efficient way of accessing elements by using their index, and index identifier their locations in the memory. So the time complexity for updating list element is O1, because as we said, accessing is very efficient and we are just assigning a value over here. So this is O1 time complexity, And the space complexity for updating an element in the list is O1 also. Because here we don't need any extra memory. We have already reserved the memory for a given element. We are just changing the value of it. This means that an extra memory is not required. So now let's see how insertion works in the list. So let me delete everything from here. We will see how insertion works now. So there are 4 ways of inserting a value to the list. We can insert an element to the beginning of list over here. We can insert an element any given location. For example, if we want to insert here, we can insert. And we can insert an element at the end of list. And the other way is we can have another list and we can take all elements of this list and append at the end of this list. So performing these operations over here, we will use list methods. So these are insert method, append method, and extend method. So let's see one by one how these methods are working. The insert method inserts an element in any given location to the list. We can use insert method to insert an element at the beginning of list or any given location in the list. Let's see how this is working. Okay, first let's print out this list. My list. Then I will use insert function. My list dot insert. If we want to insert an element at the beginning of the list, we will use index 0 because the first element in insert method is index, and then second element is the value that we want to insert. For example, if I put 11 here, and one more time let's print out the list to see the value and save it. Let's run it. You see that new element is added in the beginning of the list. So before our list was like this, now our list is like this. So the first element in the list is now 11. So if you notice that when we add an element in the beginning of list, all elements have to move one step right. So before 1 was in the 0 index, now 1 is in the first index. So each element has to move one step right. So as you see like this. And this is very time consuming operation because imagine that if you have millions of elements in the list, so this will take too much time to move each element one step right. So we can use insert method to insert an element in any given location. For example, if we want to insert an element over here, we will use index 4. For example, let's add 15 and let's run our code. You see that in the place of 5 we have added 15, but the 5 is moved one step right, and the 6 also moved one step right, and 7 also moved one step right, and this causes the performance problem in the application. Now let's continue with the other method, which is append method. So with the append method we can only add an element at the end of list. So this works like this. We are writing the name of list and dot append. We can write any element that we want. For example, 55. Let me just take print from here and put it here, and let me comment out this line over here and run our code. You see that 55 is added at the end of list. By using append method, we can add an element at the end of list. So this is very efficient way of adding element because in this case, we don't have to move any element right or left. That's why it's just straight away added the elements over here. The third method that we can add an element to the list is extend method. By using extend method, we can add another list to our list. For example, if I create over here new list, which will have some new values, let's put 11, 12, 13, 14. So by using extend method, I can add this list to my list. So extend new list, save, let's run our code. So you see that all elements in the new list is added at the end of this my list. So before the list was like this, now all elements from the new list is added here. So what is the time and space complexity for these methods? So as we said, when we add an element using insert method, we have to move all elements one step right. So this means that the time complexity will be O(n) for this method over here. Because every time after adding, we have to move each element one step right. Then we continue to append method. We said that when we use append method, we are just adding an element at the end of list. So this means that this is very efficient. We are not moving any elements right. So the time complexity for this method over here, append, will be O(1) time complexity. And the space complexity is O(1) because we just need one location for each element. Then we are continuing to extend method. With extend method, the time complexity depends on the elements of the list. This means that if we have n number of elements over here in the new list, so the time complexity for extending to a new list will be O(n) time complexity, because the way that it works is just looping through all elements of the new list and adding them one by one at the end of the list that we want to add. So as you see here, we declared our list in this way and it added elements the same ordered way. So here the first element is 11, and you see that after addition the first element over here is 11, then 12, 13, 14, which means that it adds the element in an ordered way that we declared. And the space complexity for this one is also O(n) because it depends on the number of the elements, how many elements that we are going to add here. If we add n number of elements, so we need to allocate n number of elements, so the space complexity will be O(n) by using extend method. So this is all for this lecture. Hopefully everything is clear about updating and inserting new elements to the list. Now in the next lecture, let's see how can we delete an element from the list. Hi there. Now in the last video we have learned how can we insert an element in the list and how can we update an element of the list. Now in this lecture we will look at how deletion in list works. Before deleting an element from the list, let's see how slicing works in the list, because we will need this functionality for deleting multiple elements from the list. For slicing, we use slice operator. So let's see how this is working in Python. Imagine that we have a list like this. So if we want to select first two elements of the list, we can do it using slice operator. So let's print out first two elements of this list. So we can use it my list. Slicing is used with bracket operators. So here we are putting 0 and 2. So by doing this, we will print out first two elements of this list. If I run our code, you see that the first two elements of this list, A and B, is printed out. So as you notice that first index here is included in our output, but the second index here is not included. So the functionality of slice is working like this. It's excluding the second index. The second index is not included in our output. So if I omit first index, it will start from the beginning and print out till the index that is before this second index. So if I remove 0 from here and omit it and run our function one more time, you see that the result is not changed. So if you are going to start from the first element, you don't need to provide it. What if I omit the second element? If I just put here 1 and omit the second element, let's see what will happen. In this case, list starts from the first index that we provide here and continues until the last element. So omitting second index here will bring us all elements from the list. So if we omit both elements from here, let's see what will happen. If I run our function, you see that it's printing all elements from the list. So omitting both elements will print all elements from the list. By using slice operator, we can update multiple elements in the list. For example, if we want to update first two elements of this list, we can do like this. My list. So for first two elements, we will start from 0, go to the second index, and second index is not included. We can put here, for example, instead of AB, we can put XY. And let's run our function. You see that After updating multiple elements, the first two elements is changed to X and Y. So by using slice, we can update multiple elements in our list. So let's see how deletion is working in the list. So there are several ways of deleting elements from a list. We can use pop method, delete method, and remove method to delete an element from the list. Let's start from the first one with pop method. To delete an element from the list by using a pop method, we need to provide an index of element to pop method. Pop method takes as a parameter index of the element that we want to delete. So here, if I put like this and call pop method, for example, if I put 1 here and print out our list, you will see that our second element will be deleted because the index 1 refers to the second element. If I just run our code, you see that second element is deleted. As we delete the second element, all elements on the right side of this element, deleted element, moved one step left. So C moved to the place of D and D moved to the place of C and continues like this. And this is very time consuming operation. So if we don't provide any index over here, the pop method will delete the last element in the list. So if we run this, you see that F is deleted, the last element is deleted. The pop method is very useful when we want to keep our deleted elements, because this function returns the deleted element by itself. So if I just print out the operation over here, you will see that it will print out deleted item. So we are calling pop method without any index, which means that it will delete the last element. So as you see, if I print out the output from here, it prints out F, which means that it deletes F. So if I just put here 2, which is the index of C, and run our code, you see that it will print out C and C is deleted from the list. Let's continue to the next method, delete method. If we don't need removed value, we can use delete method. Delete method also works based on index. Okay, let's see how delete method is working. As I said, it's working based on index as well. So here we need to call delete my list. For example, if I want to delete first element, I'll save it. For now, I'll just comment this part and run our function. You see that B is deleted. So in this case, index 1 is the index of B, so B is deleted. So here, if I delete, for example, the third element, you'll see that 0, 1, 2, 3, D element will be deleted. So D is deleted. So this is how the deletion method is working. In this case, this function, delete function, is not returning anything. By using delete method, we can delete more than one element using slicing. For example, if you want to delete first 2 elements of this list, I can just put here 0 to 2 and run our code. You see that A and B is deleted. If I just change it to 2 to 3, let's put 4 here, it will delete starting from the second index till 3 index. Second and third index will be deleted. So here the index of 2 shows the third element, so which means that third and fourth element will be deleted, and C and D is deleted, as you see from the output over here. Let's continue to the last method, which is remove method. The remove method is very useful when you know the element itself. You don't need to know the index. You can just provide the value and delete that value. Let me just comment out this part also. So call remove functions, mylist.remove. Here, for example, if I want to delete element E, if I save it and run it, you see that element E is deleted. So this is how remove method is working, and it's very useful when you want to delete element itself without knowing any index. So let's see what is the time and space complexity for this function. To remove element by using pop function, if we just use it without any parameter, it will delete the last element, and this means that the time complexity will be O1, because deleting last element is not causing any shift in our list. So the time complexity for deleting last element using pop function is O1. But if we use pop function to delete an element from the beginning of the list, then the time complexity will be On, because if I delete the first element, the rest elements have to move one step left. So this means that it will take too much time if we have more values. The space complexity for all these methods will be O1, because there is no requirement for extra memory to perform any deletion. So let's continue to delete method. Delete method also takes On time complexity, because here when we delete any specified element or multiple elements, the rest elements have to move one step or more steps to the left. So this means that the time complexity will be On. Now it comes to the remove method. Remove method also takes On time complexity, because here we are providing the element straight away, which means that if you provide first element, all elements have to move one step left. So the time complexity will be On. As I mentioned, space complexity for all these methods is O1. So this is it for deleting elements from the list. Hopefully everything is clear now. Hi there. In this video, we will look at another operation that we can perform on a given list. Here, we will search for a given value in the list. This means that we will check if a given value exists in the list or not. Let's say we have a list like this, and we want to look if a value of 20 exists in the list or not. So, how can we find out that if the value exists in the list or not? Here, in this lecture, we will look at two options. First option is by using in operator, which is built-in functionality of Python. The second method is using searching algorithms. Now in this course we will learn type of searching algorithms, but here I will show you the simplest one, which is linear search, which means that we are visiting each element of the list and checking that if this is the element that we are looking for or not. So let's see how this is working in practice. Okay, the first method is by using in operator. In operator works like this. For example, I can write if condition if 20 in my list, then I can print out the index of this 20, my list. By using index functionality of list, we can find the index of any given value. So here if I put 20, if this exists here, it will show what is the index of 20. Otherwise, we can print out that the value does not exist in the list. So I'll print out like this. The value does not exist in the list. So let's run our code. Let's save it, then run it. You see that it returns 1. The index of 20 is 1. Let's check from the list. This is the 0 index and this is index 1. So the value exists here. For example, if I write 100 over here and save it and run our file, so you see that the value does not exist in the list, which means that 100 does not exist in the list that we created over here. So you might be interested what is the time and space complexity for this. The time complexity will be On, because in operator works the way checking all elements one by one and returning the value. So by checking all elements one by one, it will take On time complexity. So let's look at the second method. The second method is linear search. So for linear search, I will create a function over here. Let me delete this code from here. We can create one function, for example, search in list. And this function will take two parameters. First parameter will be the list, and the second parameter will be the value that we are looking for. Then we will create a loop for I in list. If I equals the value that we are looking for, then we will print the index of this, return list.index of this value. Otherwise, we return value does not exist in the list. So let's save it and run it for example, one more time for 20. Search in list. As a list, we will take my list and the value will be 20. And let's print out the output from here. So if we print out output, let's save this and let's clear this. Okay, let's run our code. You see that it returns 1. So which means that the index of 20 is 1. If I put, for example, 50 over here and run our code, you see that it returns 4. So which means that the index of 50 in this list is 4. So let's see, this is 0, 1, 2, 3, 4. So which means that our function is working properly. So if I write, for example, 100 over here and check it, you see that the value does not exist in the list. So what is the time and space complexity for this function? The time complexity will be O(n) time complexity, because if we start from here, we see that returning a value from the list is O(1) time complexity, and if condition over here is also O(1) time complexity. So the time complexity for the loop over here is O(n) time complexity, because here we are visiting each element of list over here. So this means that this will take O(n) time complexity. So if we combine all time complexities over here, we see that the time complexity for this function will be O(n) time complexity. And the space complexity is O(1), because here we don't need any extra memory to execute this function. So in this video, we have learned how to search an element in the list. So we did it in 2 ways, by using in operator and linear searching algorithm. So hopefully everything is clear now. Hi there. In this lecture, we will look at list operations and list functions. So let's start with list operations. The first operation is plus operator, which concatenates the list. So let's see how this is working. Imagine that we have 2 lists. The first one is A. Let's see. It consists of 3 elements. And the second one is B. B also consists of 3 elements. I'll put like this. 4, 5, 6. So by using plus operator, we can concatenate these 2 lists and create one another list, or just print out the result. In this case, I will just create another list, C, which will be concatenation of these 2 lists. So if we print out C, and save and run our code, you see that the list of C is now consists of both elements from the A and B. It's concatenation of A and B. So by using plus operator, we can concatenate 2 lists together. It doesn't matter how many elements we have here. If we put, for example, another element over here and save and run it, you see that 7 is also included over here. So this is how plus operator works. So let's continue to the next operator. The next operator is star operator. So by using star operator, any element in the list can be repetitive. It means that, for example, if I have a list like this, for example, with the element of 0, if I use star operator and multiply this with 4, you will see that we will have this element 4 times repetitive in the same array. So I can put like this, A equals A star by 4. So let's run our code. Let me print out A. So let's save and run our code. You see that 4 is repetitive 4 times. So if I add another element over here, this time these 2 elements will be 4 times repetitive. Let's run our code. You see that now 0, 1, 4 times repetitive, which means that by using star operator over here, so we can make our elements in the list to be repetitive. So these are 2 operations that we need to know about list operation. So let's continue to do list functions. There are a number of built-in functions in Python that can be used on list that allow you quickly look through a list without writing your own loops. The first function that we are going to use, len function. So instead of writing a loop and counting elements of the list, we can use len method to count the elements of the list. So imagine that we have a list like this. Let me delete code from here. Let me put a few more elements over here. Imagine that we have a list like this. So if we want to count element of this list, we can use len function. Len, and then inside we will put list name. Let's run our code. You see that number of elements is 7. So which means that we have 6 elements over here plus this 0 is 7. This helps us to write efficient code, because normally when we count a number of elements in the list, we have to loop through list and count them one by one. But in this case, we don't need to use loop. We are just using let function, and by using let function, we can get the number of elements in the list. So the next function is max function. So by using max method, we can find the maximum element in the list. Once again, this is helping us to eliminate loop, because instead of writing loop to compare elements one by one, we can just write max method to find maximum element in this list. For example, if I just use it over here, max a, you will see that the number it will return is 6. So let's run our code. You see that maximum number over here is 6. So the next method is min method. So by using min method, we can find the minimum number in the list. It's working same way as the max method, but here it returns minimum number in the list. So if we select like this and save it, run our code, you see that the output is 0, which means that the minimum number in our list is 0. So this is how minimum method works. So the next method is sum function. So by using sum method, we can find the sum of these elements in the list. This is also very efficient. Instead of again writing loop, we are just summing up the elements. The syntax is same. We are just calling sum function with the parameter of a. So if we run our function, you see that it returns 21. So if we sum these elements over here, we will get 21. These functions are very useful when developing a software. By using combination of these functions, we can easily calculate other functions as well. For example, if we want to calculate average of this list, we don't have such function, but by using the functions that I explained here, we can find the average. So we know that the average is the sum of elements divided by the number of elements. So we can find sum of elements with sum a and divided by number of elements. So how can we find the number of elements here? So we learned that by using len function, we can find the count of elements in the list. So if I put like this and save and run our code, you will see that the output is 3, which means that we have 7 elements over here, and the sum of these elements are 21. So 21 divided by 7, it is 3. So by using combination of these functions, we can find other functions as well, which are very useful in this. So here I prepared a challenge for you. By using these functions, we will do a challenge. So let's imagine that we have a code block like this, in which we are taking the numbers from the user and finding the average of this number. So if we run our code, you see that it asks to enter a number. So if I enter 1 and press enter, again it asks another number. So if I enter 2 and press enter, again it asks another number. To end this series, we just need to put done. When we put done, it will automatically give us the average of these numbers. So if I put here done, you see that the average is 1.5, which means that 1 plus 2 divided by 2 is 1.5. So this is how our block of code is working. As you see here, I declared 2 variables which initiated 0. Then inside while loop, here we are asking for user to enter a number. If a user enters done, then it exits from the loop. Otherwise, it continues to convert the number that user entered to float. And in total variable, we are keeping these values. Every time we receive a value, we are adding to the total. And in each loop, we are counting the number of loops. So at the end, we are calculating the average of these numbers. So now here, I want you to convert this block of code over here by using list and list functions. So which will make our code more efficient. So now here, I want you to pause the video and think if you can convert this block of code to the code that will use list and list functions. So pause the video now. Okay, now see how can we convert this block of code to the code that will use list. So here I will create a new list, and instead of using these variables over here, I will use the list to keep the values that the user enters. I will delete this variable over here. Instead of these variables, I will create new list. So here I will create my list like this, which is creating empty list. So then we start looping. While it's true, we will loop. This part will remain same because user has to enter numbers, and when he or she enters down, it should break. And this part also will remain same. We need to convert this to the float. So here, instead of keeping the values in the total variable, I will use my list and append. Then I will add the value that user enters. So which means that every time a user enters a value, this will append our list. So I don't need these two parts over here. So at the end, we need to calculate average of this list. So how can we calculate average of list? So let me put this average variable outside loop. So here we will take sum of my list, and here length of list, which will give off number of elements in the list. So length of my list. So if I run our code now, you see that it asks to enter a number. I will enter 1, 2, 3, then done. You see that the average is 2. So if we sum up these elements over here, we are getting 6, and 6 divided by 3 is 2. So you see that here we used list and list functions to convert the block of code that we wrote before to the function that use list and list functions. So this makes our life much more easier. So now hopefully everything is clear about list operations and list functions. So by using these functions, you can write more efficient programs. So that's all for this lecture. See you in the next lecture. Hi there. Now in this video, we will look at how can we create a list from string. So we know that a string is a sequence of characters and a list is a sequence of values. But a list of characters is not same as a string. So to convert a string to a list character, we can use list function. So let's imagine that we have a string like this. A string, for example, like this, spam. If we want to convert this string to the list, we need to use list function. So here I will create B as a list function. Inside here we will call A. So if I print out B, you'll see that the list is created. So you see that every character here converted to the element in the list. So we can access this first character by using index 0 and this P index 1, and it continues like this. The name of list is built-in function in Python. It's advisable that not to use list as a variable name. So you cannot mix them. But there might be situations you want to break a string into words. Then you can use split method. So let's say that we have 3 spam over here, and we want to create a list from this string, but every element we want as a word. So for this case, we are using split function. The split function is working like this. So here I will call a.split. Then you will see that this is creating a list of B with the elements spam, spam, spam. Let's run our code. You see that from this string we created a list which consists of 3 elements of spam. So if we want to access second spam over here, we can use list index of 1 and access to this element over here. As you see, here the delimiter is space, between these words. For example, if we have a string like this, I'll put like this spam 1, spam 2. How can we convert this string to list? Because in this case, we don't have any space between elements. In this case, we can use an optional argument called delimiter, so which specifies which character to use as a word boundaries. So for this example, we can use, for example, dash as a delimiter. So we need to do like this. Before creating list, we can create any variable delimiter like this and assign it to dash. So in this case, when we create a list, we will call delimiter parameter inside split function. So if I run this, You see that by using delimiter parameter over here, we are able to convert this string to the list. So we can use any character that we want over here to convert a string to the list. For example, if you see that we have a repetitive here, if I put a here and run our function, you see that the string is converted to the list based on delimiter a. So that's how the split function is working to convert a string to the list. Okay. There's another function which is converting list to string. So by using join function, we can revert back these elements to a string. So to use join function, we will call delimiter dot join. So here as a parameter, I will put the list that we want to join. So you see that after calling join function, we created a string based on the elements from this list, and we have provided as a delimiter a, so that's why this string comes back to the way that we had before. So these are the functions that are useful for converting string to list and list to the strings. So this is all for this lecture. So in this lecture we have learned how can we convert the strings to the list and list to the strings. Hopefully you have understand the functions over here. Hi there. In this video we will look at drawbacks of lists. This means that careless use of lists can lead to long hours of debugging. Here are some common pitfalls and ways to avoid them. The first one is, we don't need to forget that most list methods modify the argument and return none. This is the opposite of string methods, which returns a new string and leave the original alone. So let's imagine we have a list like this. So if we use the sort function for this list like this, my list assigned to my list dot sort, and let's print out our list. You see that the return is none. My list is now none. This means that many operator or methods in Python modifying the list and returning none value. So we cannot use these return values for the next operations. The best way to avoid such misunderstanding is to read the documentation carefully and test them in interactive mode. The best place to check is docs.python.org. So let's look at the second problem. The second problem with list is that there are many two ways to do things. For example, to remove an element from a list, you can use pop method, remove method, or delete method. Or even a slice assignment can be used to remove elements. So these many ways of doing things might lead some misunderstanding. This means that, for example, if we want to append this list over here, we can call append function and, for example, add 10 here. So if I print our list and let's run our code, you see that the element is added at the end of list. So another way of adding an element to the list, we can use concatenate operator. Here the operator works like this. My list equals my list plus element 10. Let me just comment out this part, save. And if I run our code, you will see that the element is added at the end of list. So this is fine. But because of these various ways of adding elements, you can mix them up. Many people can mix these two things. Instead of appending just element, we can write something like this. If I write like this, this is the wrong execution of the adding element. So if I run this code, you see that everything is working fine, but it's not adding an element at the end of this list. It's adding another list inside this, which is the nested list. So this is not the right way of doing this. Because of the many ways, we can mix these ways. The best way to avoid such problems is try out each of these examples in interactive mode to make sure that you understand what they do. The most important thing here is that notice that here this way of adding element is not giving any error. It's just adding nested list, which will cause problems in the future if we do any operation on this list. So let's continue the third problem. The third problem is whenever we do any operation on list, we need to take copy of this list because many methods modifying original list itself without keeping the original one. So for example, if we sort this list, we will see that without keeping the original, it's sorting the elements. So the list is sorted. It modified our initial list. So the best way to avoid such problems, every time we need to take copy of this list over here. We can do it like this. Original list equals to my list. Something like this. So if I do like this, and let me print out our original list over here. So if I run our code now, you see that this is our original list, it stays as it is, and this is the sorted list. So here we can avoid this problem by keeping the copy of it. But in the case of sorting, there's another function which is keeping the original. We can use sorted function over here, which will not cause any problem to the original one. For example, if I do like this, sorted function, my list, and if I print out our list, you see that the original list is not changing. This is not touching the original list, it's just returning the sorted version of the list. So this means that to avoid such problems, we need to look at documentation very carefully to look for an alternatives. If we don't have any alternative, we need to keep the original list. So in this lecture, I tried to give you a brief explanation of drawbacks of lists and the ways to avoid them. So the best way to avoid any problem with the list is to read Python documentation very carefully. Hi there. In this video, we will look at what are the differences and similarities between arrays and Python lists. Let's start with similarities. The first similarity is that both data structures are mutable. It means that we can update elements of both data structures. So by using their index, we can update any element in the list or in the array. The second similarity is that both can be indexed and iterated through. This means that we can access their elements by using their index and we can iterate through them. In the previous lectures, I showed you how to iterate through the list and how to iterate through arrays. And the last similarity is that they can be both sliced. This means that by using slicing functionality, we can slice both lists and arrays. This functionality also was shown in previous lectures. If you go back to list lectures or array lectures, you will notice that we explain slicing in both cases. Let's see what are the differences. The main difference between these two data structures is the operation you can perform on them. Arrays are especially optimized for arithmetic computations, so if you are going to perform similar operations, you should consider using array instead of list. Let's imagine that we have an array like this, my array. I'll create an array using NumPy model. So I imported NumPy model over here. So here I'll create an array. Let's create an array of integers like this. It will start 1, 2, 3, 4, 5, 6. I will create another data structure which is list, my list. It's going to be also integers. So the difference is that if you want to perform any arithmetic operation on this list or array, on list we cannot perform it. On array we can perform it. Let's do like this. I'll print both cases. For array, if I divide it by 2, this will work. You see that each element of array is divided by 2 and written over here. So if we divide 1 by 2, it's 0.5, and then 2 divided by 2 is 1, and it continues like this. But if I do the same operation on list, you will see that we are receiving error. I'll copy it from here and put it here. Let's run our code. You see that we are receiving an error in this case. So which means that if you are going to do some computations on the data structure, it's better to use arrays. Arrays are optimized for this. So the second main difference is that in list, the elements data type can be different. But in array, all elements has to be same data type. Which means that, for example, if I put here extra element A, and here also A, if we print out both cases, let me print array as well, you will see that in case of array, these elements over here will be converted as string. So this will not be recognized as integer over here, which means that the data type must be the same. So let's run our code. You see that in case of array, we are printing array first. All elements is string. Even though we declared it as integer, it's converted as a string. But in case of list, these are integers, but this element at the end is string, which means that the data type can be different in case of list. But in case of array, the data type has to be same. So this is the main difference between them. So in this lecture, I tried to briefly give you what are the similarities and differences between array and list. Hi there. In this video, we will look at time and space complexities in Python list. In previous lectures, we have discussed about all operations over here, and we have discussed about time and space complexity of these operations. Here I'm just giving you big picture of this time and space complexities all together. So the first one is creating a list. Creating list takes O1 time complexity because we are just creating a value and assigning everything all together. But the space complexity for this is On because it depends the number of elements that we are creating for a list. Then the next operation is inserting a value in a list. Inserting a value in a list can be O1 time complexity or On time complexity. Because if we insert an element at the end of list, then it takes O1 time complexity. Because in this case, we are not moving any element right. But if we insert an element in the beginning of list, then in this case, all elements have to move one step right. Which means that if we have an element in the list, then we have to move n number of elements one step right. So this will take On time complexity. The space complexity for inserting a value is O1 because we are just inserting one value. Then we are going to the next operation, which is traversing a given list. Traversing a given list is On time complexity because here we are visiting each element of list. This means that if we have n elements in the list, then we have to traverse n steps through the list. So this will take On time complexity. Here again, space complexity is O1 because an additional space is not required to do these steps. Then we are continuing to the next operation, which is accessing a given cell. As we said in arrays, accessing a given cell is very efficient in arrays. Here it's the same. Because based on index, we can identify the location of the cell in the memory and access it directly. Here, any iteration is not required. That's why the time complexity is O1. This is very advantageous part of lists and arrays. So the space complexity for this O1 because here again an additional memory is not required to do this operation over here. Then we are continuing to the next operation. The next operation is searching a given value. So searching a given value in a list is On time complexity because if we search a value in a list linearly, then we have to visit each element of list and compare the value that we are looking for. If the value is same, then we are returning. This means that in the worst case, we can traverse all elements in the list and find the element that we need. So here, the time complexity will be On. The space complexity one more time is O1 because here again, no additional memory is required. Then we come to deleting a value from the list. So if we are deleting the last element from the list, this will take O1 time complexity because in this case, no additional steps are required. But if we are deleting an element from the beginning of list, then in this case it will take On time complexity because if we delete first element from the list, then all elements on the right have to move one step left because here we cannot keep the first element's place empty. All elements have to be contiguous. That's why all elements have to move one step left. So this will take On time complexity. And the space complexity one more time here is O1 because we are just deleting the element, no additional space is required. Now this is all for this lecture. Hopefully all operations are clear now and you know the time and space complexity of these operations in list. Now in the next section, we will look at top interview questions that are asked by big companies related to list and arrays. See you over there.